Hi everyone, my name is Benjamin Wellmond. I'm a documentary filmmaker from Los Angeles, and I was very interested. I met Nam, and he told me a lot about your group, and I was very interested in what you guys do and the things that you guys are interested in. So I felt this is a very natural conversation for us to have. I'm just curious, how many of you guys know what synthetic biology is? You can raise your hand if you know what it is. Zero idea. That's awesome. That's fine. Exactly. Okay. No problem. So I'm going to talk to you about, first, a little bit about synthetic biology, and then we're going to start to talk about what my documentary was about, which is DIY biology and bioart. And then we'll move from there. So the first question is, what is synthetic biology, right? So synthetic biology is when you apply the principles of engineering to biotechnology, or when you manipulate biological devices or systems for a variety of different purposes. So what you're essentially talking about is you're talking about a living system, like a DNA or a bacteria or something like that, and you're using that system for your own purposes, for purposes outside of what it was specifically designed to do in the first place. So you're doing this work in a laboratory rather than it happening outside in nature. Does that make sense to everyone? So synthetic biology has a variety of different uses. The first and the most prominent one that you guys probably know about is medicine. For instance, a good example is vaccination. You guys know how vaccination works? So with vaccination, what happens is you introduce a dead piece of bacteria to your body, and your body learns about how to stop that bacteria from infecting you. So we're taking a piece of bacteria, living matter, and we're using it for our own purposes, right? And the other subject that you probably know a lot about is agriculture. And this is genetically modified organisms, GMOs, which I'm sure is becoming an important subject that everybody likes to talk about these days. So what's happening there is that we are manipulating the DNA within the seed of the plant so that when it grows, for instance with Monsanto's, right, what happens with Monsanto's plant is that it's resistant to the chemicals that you spray on the plant, right? There's also many other uses for it. For instance, synthetic biology is starting to be used for energy. So there's certain bacteria that will take oil, crude oil, and will process it and turn it into more refined oil that can then be used for cars and automobiles and stuff like that. And they're also thinking about using the bacteria itself to begin to generate more energy. But that's something way, way in the future. And they're also beginning to use it for manufacturing. So, for instance, there's an organization called Ginkgo Bioworks, and what they do is they create living systems that will replicate what a chemical system would do. For instance, Coca-Cola, right? There are certain chemicals that are created in Coca-Cola that are done through a chemical process. But this process is expensive, and it's also very wasteful for the environment, right? So Ginkgo Bioworks, what they do is they use a piece of bacteria that would basically do the same thing that the chemical process would do, but it would all be done through a living system. So obviously, as you guys can tell, this is a technology that is becoming an incredibly important part of everyone's lives, right? The medicine that you take and the food that you eat, and now the chemical processes and the energy systems that we are beginning to use, it's becoming a very prominent and very important part of our lives, right? So I want to give you guys a little bit of a historical background to where we got today, where we got to the point that me and Mary are at with DIY biology, okay? So I want to start with, in 1878, this guy was the first to discover nucleic acid. When he first found it, he actually didn't think it had any purpose. He just thought it was a chemical that existed in the nucleus of an atom, of a nucleus of a cell, and so it was this, as you can see here, right there is the nucleus, and this is not how it actually looks like. But the idea is, within the nucleus, there was a certain chemical that they didn't really understand yet, but after doing research, they kind of came to the conclusion that this chemical had a lot to do with heredity, which is essentially the traits that you inherit from your parents, right? So, but at this point, there isn't a lot of information. The technology, in order to understand DNA, wasn't very powerful, so we didn't really understand exactly how it worked, right? Fast forward about 80 years later, and these two guys, James Watson and Francis Crick, are two scientists who finally discover the structure of the DNA molecule, or the nucleic acid molecule, right? Which looks like a double helix, like that on the right-hand side. And this is one of the first microscopic images of the DNA molecule, or what they came to use this to understand how it looked like. So essentially, if you can see here, the DNA molecule is made up of two strands, right? And these two strands are made up of 4 different chemicals. And when these chemicals interact with each other, they basically are telling the DNA to produce different traits, right? Like blue eyes, or hair, or skin tone, or things like this, right? Does everybody understand that? I know that's a lot. So essentially what happens is through a process called DNA synthesis, whenever there's reproduction, what happens is the DNA strand separates, right? And then it combines with the strand of the other mate, right? And that's how DNA synthesis happens, right? And that's how you carry traits from both parents. So just to give you an example, right? It's obviously a little bit more complicated. I'm doing the very simple version of it. But for instance, you can see here, these would be the two parents, the female on the top and the male on this side, right? And as you can see, this would be like all the different variations of a certain kind of plant that is inheriting those traits. So obviously, this more complex understanding of the DNA molecule led to a lot of different innovations, both in the field of agriculture and medicine, right? But the issue is that the issue became that the issue became that these, in order to do more research, is really, really expensive, and because we didn't really understand living life, you couldn't put patents on these things yet, right? So all of the research that was being conducted was only happening within schools, right? Universities, academic settings. But then in 1980, there was a scientist by the name of Chakrabarty who basically engineered a piece of bacteria to take oil, crude oil, and turn it into more refined oil. Does that make sense to everybody? And so he had this new technology, and he was working for a company called General Electric, right? And it was very expensive to develop this bacteria. So he went to the patenting office and he said, "I want to patent this." And the patenting office said, "I'm sorry, you can't patent something that's alive. You know, I'm sorry, we won't let you do that." So what he did is he sued the patenting office, and the case went through court, and it went to the highest court in the American system called the Supreme Court. And the Supreme Court finally ruled after this case that because of the fact that this has been developed in a laboratory, and because so much time and so much money had been put into this project, that there's no reason why you can't put a patent on living life, right? So this had an incredibly fundamental impact on the way that people interacted with this technology economically. What you saw started happening is a lot of big businesses started moving into patenting for synthetic biology projects, especially within the realms of medicine and agriculture. Essentially what these companies were doing is they were buying up all these patents for different ways that we could genetically engineer plants or medicine, and now today we're at a point where this is where the money is in terms of biology and biotechnology. It's in purchasing patents. If you don't have a patent for the object, or if you don't have the funding to develop the patent, then there's no point in doing research. And so what starts to happen because of this is all these businesses start to buy up all these patents that are really wealthy, and a lot of monopolies start to form. Do you guys know what monopolies are? Essentially, it's just there's not that much competition within these realms anymore. And just to give you an example, I found this study, which is really interesting, but basically these 10 companies right here, which are all GMO companies or all seed aggregate companies, own approximately 67% of the entire global proprietary seed market. So that means all the seeds in the entire world more than half of the seeds in the entire world only come from 10 different companies. I know that you guys are planning on having a discussion about GMOs, and I think that's an incredibly important thing to be thinking about, that these companies are very, very powerful, and they own a lot of what's already happening. They own a lot of our food supply. So in 1995, so up until this point, we have a good understanding of how the DNA molecule works, but it's still pretty expensive and pretty hard for us to analyze everything that's going on. So the government and some corporations fund the Human Genome Project, and this is the first time that we have a complete understanding of the entire human genome. And from the year 1991 to 1995, essentially, we do a research, and we use a variety of different techniques to find out about the human genome, and the study is released that basically releases the entire human genome. So the entire human genome is sequenced. That means we know every single part of the DNA that makes up the human genome. And this process was incredibly expensive. It took a lot of scientists, but what is starting to happen now, or what happened since then, is that, like all computer systems, the prices in order to analyze this technology and recreate it has dropped significantly. Do you guys know about the concept of Moore's Law? Okay, so Moore's Law is a theory that essentially every 18 months, the cost of technology will drop exponentially, right? So in the year 1900 or 1910, you see this computer chip, like computers are huge, right? Like a computer in 1950 would have to fill up this entire room, right? And then today, a computer chip is this small, right? And it costs a fraction, and people can own their own computers, right? So that's the concept of Moore's Law, as every 18 months, basically it changes exponentially, and it gets cheaper and cheaper and cheaper and cheaper and more accessible and more accessible. Now, the same can be said for DNA sequencing, right? So the Human Genome Project, right, takes 4 years and $3 billion to complete, right? And today, 23andMe is a company in the Bay Area, and what they do is you can send in your saliva, and they'll analyze your genome. And this process costs you $100, and it takes a month. So you can see that the cost of DNA of DNA sequencing and DNA synthesis has dropped incredibly. So you can see here, for instance, in the year 2002, it cost per genome, right, $100 million, right? And in the year 2014, to do that same process, it costs about $8,000. So once again, you can see that the prices are dropping exponentially, right?
Ben, can you put me that vase?
What's that?
Put me that vase here.
Oh, thank you.
Put it down.
That'll be a little bit easier. Great. So what's also happening, right, is along with the tools that you can use to do your biological research are also becoming much cheaper, right? So this is a PCR machine, and it's an essential device for when you're doing your biological research. what it essentially allows you to do is take DNA strands and multiply them, and therefore, there's more of them, and you can do more research with them. In the beginning, 20 years ago, something like this would cost, $10,000, right, or something like that. And today, you can buy it for $200. And what also is happened that's very interesting, and we'll talk about it when I get to DIY Bio, is in 2008 there was the American recession, and all of these tools that existed in these laboratories, all these laboratories, mainstream laboratories, were going out of business. So all of these tools that were being used in these laboratories were being sold on eBay, for a fraction of the price that they had been bought for. So something that costed, $10,000, $20,000 could now be bought for like $2,000 or $3,000, right? And this is kind of where DIY biology comes in. And this is in about 2008, two MIT students, Harvard students, I'm sorry, named Mackenzie Cowell and Jason Bobe. They thought it would be, they thought it would be really interesting to see what would happen if they took all of these tools and all of these processes outside of a laboratory, outside of an academic laboratory, and bring it into their own homes and do it as a project, as a hobby, for fun, And it was the first time that anybody had ever, done this before, or arguably, that's arguable. But anyway, so they started a website called DIYbio.org. And that was, the idea of the website was to provide resources to people that had the same interests as them, right? And so what started happening is a lot of different spaces started to prop up all over the United States and all over the world. And the way they work is, you guys familiar with the concept of a hackerspace? So essentially, the idea is that you pay a membership fee and you have access to materials in order to conduct projects. But these spaces were specifically oriented to do biology, right? So you had, wet laboratory equipment, PCR machines, things like that. Today, there are spaces all over the world, right? So you can see there's a bunch in North America, there's some in Europe, there's some in Russia, there's some in Australia, and I'll provide you guys a website, but they all have different interests based on the political environments, based on, for instance, this space right here, GenSpace, they're located in New York. So New York is very well known for their art world. So you see a lot of art projects go through GenSpace. Whereas in BioCurious is located in Sunnyvale, California. So what that means is you see a lot of more business-oriented projects, people that are trying to start startups, because it's right in the middle of the Bay Area where there's a lot of these startup companies. So, and in Europe it's much, much more political. So it's people trying to ask political questions and trying to raise discussion and stuff like that. But the other part of the project, the other part of our documentary, focused on another aspect of, we'll call it non-institutional biology, right? And that refers specifically to bioartists, right? Because there were a lot of people who were thinking critically about these technologies and were saying, well, these technologies are affecting all of us every day, right? And they thought, well, I think it's important that we start asking questions about how these technologies influence us, So, for instance, on our left-hand side is an artist called Steve Kurtz, and he is featured in the documentary, which will hopefully work. And he was an artist that started asking a lot of questions as to how how we are educated on these technologies, right? And he started to, one thing he did that's a very famous piece of his is he hacked a Monsanto seed to make it so that the seed, because the way Monsanto's works is you get the seed and then it becomes, resistant to to the pesticide that you spray on it. So he hacked the seed so that it would no longer be resistant to the pesticide, to kind of make a statement. And this guy in the middle, Adam Zaretsky, he's really crazy. He does a lot of performance art-based work. And then the woman on the very right-hand side, what she does is this very, very interesting work. What she does is she finds leftover pieces of trash from people, so hair and cigarette butts and things like this on the floor. And she runs it through a PCR machine and then she runs it through a program, and the program can analyze and basically make an estimation as to what that person might have looked like based on their DNA. And based on that, she's able to make these sculptures. So that is somebody's face. But so as you can tell, it's a lot of people that are using these technologies to kind of ask questions about what's going on in these environments and stuff like that. So anyway, so that brings it to us. So to me and Mary, who hopefully we can get her on Skype and get that working, because that would be great. She is, I was a film student and she was a artist with a biological background, so she did art with biology. Her work, she did primarily plant sculptures, so she was working with hydroponic technology to build sculptures out of plants, and she started asking herself about, well, what's going to happen, when I graduate from school and I no longer have the resources to do this work. And so she started finding out about all these DIY biology spaces, and she said, well, this is really interesting. This is something I think is really cool. And so we started talking about it, and we realized, there's a lot of implications to taking this technology and making it available to everyone, right? Because this means that people can start asking questions about how this technology is affecting their lives. So I became interested in that, and I have a film background, and so it just made sense that we would make a documentary about these subjects. So we did what's called a Kickstarter, and I think you guys have Kickstarter here. You guys know what Kickstarter is, right? So we raised some money online. We begged all our family and friends to give us some money to make a movie, and they were nice enough to do that. And we raised about $8,000, and we traveled across the country. We started off. Okay. All right. Started off in Pittsburgh, Pennsylvania, and we did a very roundabout trip across the United States. We interviewed a variety of different artists and scientists and DIY biologists, people with synthetic biology backgrounds, people that were starting these spaces, people that are asking questions. We interviewed a total of about 50 different people, and we are putting together, this is kind of a thematic organization of all our different themes that we were interested in. So you can see that we're talking, this is each one of our episodes. So we're dividing it up into a web series, where each episode will be focused on a different theme. So like the first episode is all about a very general introduction to DIY biology. And then we get into questions like, why are people afraid of these technologies? What does it mean for the government and for corporations to know about our genetic makeup? Artists that are manipulating life, what are the ethical questions behind this? Things like that. What are the business potentials of working with this technology? And what does the future look like for DIY biology? So now we're going to try to watch.
I was blown away by the concept of people starting their own labs and turning it into somewhat of a hangout spot for scientists. Thinking to myself, we should do that. We can do that.
The task for us is to become literate in evaluating our sources. The answer is not that we can just say, okay, I'm going to leave it up to the experts.
There's this identity that was constructed over the last 100 years. Culturally, we tell our stories that scientists are these special geniuses, that you have to be really amazing and dedicate your life to this like monk-like pursuit of science and research. You don't have to go get a PhD to be a scientist at all. You just have to follow the scientific method and try and find something new in the world. Why does the public think that you have to be classically trained, or let's say institutionalized, to use biotechnology?
There's a lot of debate and philosophy behind what the hacker ethic is, but to me, it's somebody who's curious and they want understanding of systems. They want to kind of peer behind the curtain and see what's really going on behind the scenes. They want to take things apart, have understanding. If you understand the concept, nobody can take that away from you. And that's why you don't have to have formal training in this.
I mean, there is a lot of complexity to biology, so people do need to learn some things. I don't think it necessarily has to be done in the traditional institutionalized fashion. I'm Patrick Daslade. I'm a bioinformatician by profession and mad scientist at night. Bioprinting is typically three-dimensional printing using biological materials. So the clearest example of that, and that's where sort of the biomedical industry is going after, is trying to 3D print an organ for transplantation. We didn't really jump into this with this idea that we're going to like print organs or anything like that. We were looking for a project at the beginning of BioCurious when we just opened the doors, where we could just get some critical mass around and get a bunch of people working on the same project. We sort of started from this realization that really the underlying technologies for bioprinting are actually very accessible. It's all based on 3D printing, inkjet printing, things like that. So we figured, let's just play around with it and see what happens. And what happened was that over the course of about a year, just meeting once a week with a continuously turning over cast of characters, we actually built our own bioprinter from scratch. And we're able to print E. coli cells on a little petri dish and like spell out "I heart BioCurious" in a couple of lines. To our surprise, it actually worked the first time around. It didn't necessarily work the second time around, but it worked the first time around. We wanted to be very community-driven, right? So where members have a lot of say in how the space works, but also very much integrated into the community around us.
So red is pet. And I remember telling him at a party, I was like, yeah, I built my own PCR machine and stuff. And he's like, what are you talking about? Like, you're full of it. And we finally got together and he saw this and he was really into it and was like, let's make this happen.
So it's like you have these negative and positive ions that help open up the pores and move the DNA through it. And so then you have this bacteria cell.
We want to make a community lab where biotechnology is accessible and democratized to anybody who's even remotely curious.
So what is DOI Bio? DOI Bio is this brand that conveys non-institutional biotechnology, access to it, and research and public labs, and access to the tools and kind of hackers and makers.
I define DIY Bio as biology happening in a non-institutional setting. We teach a create your first GMO class where we make glowing. Worked a lot at BioCurious, helped in the founding of BioCurious, building their lab, teaching their first classes, and have been floating around the DIY biospace since then. Central goals and missions of biospace are education, first of all. This is a space to get people who have not been doing biology for years or not been doing biology at all to be able to understand the potentials of biology, and specifically synthetic biology. Mission number 2 is to develop the technologies in the ways that are actionable.
The whole idea is to promote science literacy and understanding that it's not a black box. It takes the intimidation factor away, that it's reserved just for specialists or people with high training, that it's approachable, it's understandable, it's fun.
It's gratifying. It makes you feel happy that you're doing something positive in the community.
It's important to me that DIY Bio is community-based because the basis of decision-making is always better when it's made by the people who are directly impacted by it.
I've got a little stick and the circle end is for putting the bacteria in.
The bacteria will last in there as long as the food
What's the
supply.
bacteria again, sorry?
It's transgenic bacteria.
To me, what's interesting is to put the whole process of knowledge production under a light so that we think about what actually constitutes knowledge, who's authorized to create knowledge and to validate knowledge. Is it only people who are labeled experts?
Well, the concluding thought is just to say, that hopefully we've brought to people just how significant, how important this issue of transgenics is.
It's up to us as artists. Who makes the representations and the narratives? We do. And it's important for us to get out there and make sure people know these narratives. I always hoped that there would be like some awesome origin story, but there's not. It's a bunch of students that were not happy with their curriculum and DIY'd, educated themselves, and it just didn't stop. And that's basically the story. As we became more interested in the digital world, the primary issue we were kicking around is what will the relationship of technology be to people's bodies?
American farmers have been growing genetically modified crops for years, from seeds engineered to resist pests and chemicals.
Now, Roundup Ready, for those who don't know, the corn is modified to resist Monsanto's glyphosate-based herbicide. So it's a whole package you have to buy. And you buy the seed and pay a lot for it. And then you can spray the glyphosate, which is called Roundup, all over your crops and not worry that you're killing the corn. So we had found a vitamin B compound. If you applied that before you applied the Roundup, the crop would no longer be resistant. So we wanted to do this as an experiment in the public. And this is kind of what I'm talking about in terms of learning in public. Because we didn't really know. I did it in my basement, and it was inconclusive.
In that particular project, we weren't attacking Monsanto in particular. This was a methodological demonstration. This was a hacking demonstration to say these things could be hacked and reversed, and that we could take these tools and use them for resistant culture. They did not just have to belong to corporations and the military. By the end of it, they walk out way more knowledgeable. They know what a GMO is. They come out knowing something and are thinking about it with reason, not their gut.
The fact that Critical Art Ensemble are performers, the fact that they're artists taking on the role of scientists, it's not so much that that presents truth, it's more that it presents a way of experiencing science and a way of experiencing biotechnological processes.
You have to show them that how they act politically makes a difference and what is at stake for them personally.
This is like a whole new democratic way of making babies. Come on up here. It's easy and fun. Okay, now. Got very involved in issues of feminist art, which for me were a lot about the body, and particularly how that applied to women, thinking about reproduction and the labor of reproduction.
We started to look at biotechnology as another technology, but one that had really deep implications for the female body in particular. As consumer, as producer, as reproducer, as the raw material for this new industry. We were very interested in, not in the art world really, but in the public sphere. How can we introduce discussion of all of these issues, into the public sphere in a different way? Because mostly it's just experts who are always expounding on, the ethics, stem cell research, all of these issues, which are huge issues, huge issues which concern everybody.
Expo Imagenics supports a woman's choice to participate in the fertility industry. Martha demonstrates how eggs and sperm are collected and combined for fertilization in a petri dish. Ladies and gentlemen, the future is now.
It's a really great way to start to perform aspects of science and science consumption publicly. You can make transparent some, not all of it, some of the processes, a lot of the language and rhetoric around biotech.
I think of the work of Sub Rosa more as research and experimentation and knowledge sharing and experiencing with people, a kind of learning. We're learning together.
That's really our role, because we know how to make these theaters. It's one of the main things we do as artists. Science has a place in resistance movements, and we need to discover what that is. It's time to create the tactics, the materials, and the process to do it. It can be appropriated and used for social justice.
This idea of the public amateur is not confined to artists. The idea is that a person consents to learn in public, who takes on bodies of knowledge beyond their own field, educates themselves, and performs not really mastery of that subject. And so it's interesting to look at the DIY, do-it-yourself biology movement, where people are trying to set up labs, they're trying to do inexpensive substitutions for the very expensive equipment. They're trying to make this available to people. It's really interesting because if you talk to people who are doing that, you can get quite a clear idea of what are normally the barriers to people getting to participate in science.
Steve Barnes, you've never studied science, have you?
No, I have not.
Risha Sommer, you ever studied science?
Only in high school.
Okay, so we have a high school biologist. So we've got a team leader right there.
But our society doesn't think about science that way, as like a routine activity that anyone could do or that should be used as a tool in everyone's toolbox. Science is seen as this activity that's associated with the scientist, and the scientist is seen as a person who works in a lab with other scientists in this faraway kingdom that you can't go to as a member of the public.
By having access to this information, it equalizes the haves and the have-not. It democratizes technology for everybody.
But really the question comes down to, do we want to have only billion-dollar companies do this? Or do we want to democratize this and actually put it in the hands of regular people?
Awesome. So that's the first episode of our documentary, and we have 6 more that we're hoping to come out with. So, we came into this fairly idealistically, and we learned a lot about what this environment actually looks like and what the challenges are. And the truth is, like we were just talking about, the community's not that big, right? And there's a lot of reasons for that. And the first is that it's still pretty expensive to interact with. Even if the cost of the tools have gone down significantly, you have to have a space that's clean, you have to have access to chemicals, you have to, all these things are still going to cost you money, and it's still going to take a lot of work, and it's better to have like a staff, and if you want to have a paid staff, obviously that's expensive. So these things are still expensive, and they're still cost prohibitive, and it's still hard to get engaged with. And you see a lot of these spaces, unfortunately, going bankrupt, because they don't know how to keep up with how to keep up with the costs. And the other problem is, along with it being expensive, it's also just very hard to work. It's still complicated, you know? We have a better understanding of it, and, you know, there are certain things we can learn by just interacting with it, but ultimately, it's still very complicated, and there's still a lot of things that, you know, even our best scientists don't really understand, you know? So, for that reason, I think it can seem very daunting for people, and these spaces have, in my opinion, from what we saw, they've remained fairly small, and there's the group of people that are in these spaces are not as diverse as we would hope they would be, you know, and the other issue that we've been seeing, and this is a more complicated issue, obviously, is the idea that sometimes people can be misleading in the way that they represent things, and when they talk about democratizing and inclusivity, a lot of it is they have an interest in trying to find new markets for products, and not necessarily in trying to bring this technology to a bigger audience, you know? So that happens a lot.
Hello?
Hey, what's up? All right, this is better, but...
Okay.
Hey, okay. So, let's talk a little bit about Hackteria. Tell us what is Hackteria?
So Hackteria.org is a really huge international online community or online network of artists, makers, scientists, engineers, etc. that are just contributing projects to this large database of open source hardware projects. So basically, I got in contact with this guy named Mark, who's one of the co-founders of Hackteria, and he was telling me the origin of Hackteria basically around 2008, 2009. BioArt was becoming a really hot topic, and it was almost becoming an institution in itself. And there was just this kind of perception that to be a bioartist, you had to collaborate with a scientist, like for 5 years or something, to learn all these huge technical skills and to create something like absolutely amazing. But actually, it doesn't really, you don't really need that much to make bioart. So that's why you see the tagline open source biological art, because he just wanted to create this resource website where you could just perform your own experiments as an artist without a lot of infrastructure. So that was the inspiration for Hackteria.org. So LifePatch is an organization, it's basically a group of 9 members, and they are much more citizen focused than many of the labs that we visited in the US. It always started with a problem that was really apparent in the community, and that was inspiration for whatever project or workshop they would have. So it's very, very just sensitive to people's needs. And it also started around the time of the cultural revolution, where people were really having that social necessity for an alternative mode of learning, because the education system there is not quite up to par, so that's why LifePatch started. And each member has a they all have very diverse backgrounds. Some of them have a background in interior design, others have backgrounds in civil engineering, or even political activism. So they have a really wide range of backgrounds, and they're just kind of joining forces to create these initiatives. So that's LifePatch. They're based in Jakarta, Indonesia. And so in April of 2014, the Hackteria Network and LifePatch decided to collaborate on Hackteria Lab, which is basically a physical manifestation of Hackteria.org. It was the 4th time that they did it. The first 2 times were in Switzerland, the 3rd time was in Bangalore, and the 4th time was in Jakarta. So I was going to play a trailer, but I don't know if the internet's good enough.
You again.
Wow.
Kan kalau dari
Bina kemarin ke sana gitu. Apa? Bina kemarin ke sana gitu.
So we need the base. We need the base. Let's put the base.
Either once, and now you smear it around everywhere.
Wash out! Beautiful bees.
Mbak Dep bikin apa nih Mbak Dep? Bikin apa?
Oh, bikin manual instruction
Untuk?
untuk WA press motor sampling truck.
Ini kita mau bikin semacam rakit yang bisa mengambil sampel air secara otomatis. Ini salah satu tabung untuk sampel airnya. Kemudian kita juga bikin rancangan untuk kabin sirkuit elektronik.
What's this next one? This is a holster for the whole thing?
All holsters.
Yeah.
This one's for a drinker.
Alright.
Is it
It's a nerve pump.
nerve pump, but not inside this? That's look, I put it there.
Yeah, that's interesting. Anyway, it's really interesting.
So they react.
So basically, Bacteria Lab was a 2-week intensive event. About 40 international participants were invited for the 2 weeks. And in addition to the 40 people, we had all the people from LifePatch, plus a lot of local groups that were part of the collaboration. So I would say in total, there were probably 60, 70 participants in total. And we were trying to, the goal was to connect international participation with these already ongoing local projects. So we had 3 ecological projects to take inspiration from. The first one was bioremediation of the soil on the Mount Merapi, which is a volcanic mountain. And after it erupted in 2008, there's just a lot of the local agriculture was affected. The second project was the River Cleanup Project, which was an ongoing project. I don't know how it is in Vietnam, but in Jogja, it's kind of a custom to just throw trash into the river, and so it's a really polluted river. And the last project is biodiversity conservation. And what's really great about these 3 projects is that it can essentially apply to any other country. I'm sure another country has a forest, another country has a river. So whatever projects we initiated around these 3 ecological projects could potentially apply to another location around the world. So this is a picture of us taking a field trip down to the river and just taking samples and with the intention of testing them back at the pop-up lab. So this is the lab that we kind of set up. So keep in mind, when we arrived, it was an empty room, and slowly we just started filling it with stuff. like either just tracking or doing stuff that we brought along with us. The first 4 days of the event was spent doing presentations to introduce ourselves and attending symposiums and going on the field trip. And after those 4 days, then the real hacking started. It's like, all right, now we're inspired, let's just hack, let's just collaborate. So a bunch of people would just kind of gather around the table and just kind of go wherever their curiosity led them. So there is this concept called a workshopology that was created, and it's basically a really informal classes. Since everyone is coming from a different background and they have a certain expertise going into the event, then it was kind of like this atmosphere of sharing and learning. And it was extremely informal. No one was claiming to be an expert. It was very hands-on. It was very collaborative. So the types of workshops we had were bread making, book binding, t-shirt making, PCB etching, making a DIY microscope. So all of these projects, they're not necessarily biology related. Some of them were just teaching, everyday skills that you can use when you're at home or when you're with friends. And the most important part is to put it on the wiki. So there's a huge database of projects, like I mentioned earlier. And so whatever workshop we had, we made sure to put it on the wiki so that someone else could recreate it. So that's kind of the whole spirit of open source biology and open source software.
Could you go ahead?
Yeah. So there's the mess. And it wasn't just hacking, we also had a lot of really meaningful discussions. This is an image of a discussion we had about immortality. And then in the final week, we had exhibition of all the projects that we made during the 2 weeks. And I guess I just want to conclude on the possibility of having Hacteria Lab in Vietnam, which I think is completely possible. I mean, Hacteria Lab just happens because someone wants to initiate it. So there is potential to initiate one in Vietnam. You never know. So that's the end of my presentation.
Cool. Yeah, we should be especially happy because, like we said, it's 4 o'clock in the morning for Mary, and she was nice enough to Skype in and say hi. But yeah, we really want to open the floor up to you guys and, ask what kind of questions, what do you guys think of all this? Do you guys think it's interesting? Do you guys think it's stupid? Do you guys think it's weird? Do you guys think it's scary? Whatever, we want to see what you guys think about it. So, questions. Yes?
So I'm really interested in how really once you have an idea, many people have good ideas, but then it's dying off really quickly because they are not getting nourished by some energy that you can put in. So for example, if you would like to start some group in Hanoi, and if you just, for example, there's one person having this idea and whom to tell and what to do and how do you how was it growing in this special case? So you had those 8 people, but how those 8 people came together online.
Yeah, how did it start? Did you hear that question, Mary?
No, can you repeat it for me, please?
She's just asking, if you have this idea, if this is something you want to do, and where do you even start? How do you find these people?
We have, actually our website has a lot of resources to look at. We have books, we have online networks. We just, I think that it's really easy to find a hackspace or community through the internet, because that's exactly what we did when we were looking for people to interview. So it's definitely possible, but I can understand if you're in a remote area that doesn't have a hackerspace nearby. you can always go on Hacteria Lab, Hacteria.org and look up projects. You can look up open source hardware projects anywhere, basically. So you can always be a self-starter, but of course it's better to do it with friends. You can even initiate your own community. But I guess it's important to keep in mind, like, don't be afraid to try. Like, it seems daunting to pick up a skill, but it's really rewarding if you just kind of do it on your own without the help of academia. So I would encourage you to try.
One thing I would like to add is just our own experiences. We really understood that this community, they're very inviting and they're totally willing to come at you and ask questions. Like, we were, there wasn't that much funding for our documentary, and despite that, every single person we reached out to, got back to us and was totally willing to talk to us and was totally willing to engage with us. So, the community might be small here, but the global community is always willing to interact with you if this is something you're curious about, And obviously, if this is, we'll put you in touch with people and we'll make things start happening. Yeah.
I think that's a very good idea in terms of getting people engaged in science, because a lot of things, technology is something, but what to do with it is not really scientists' job. Not scientists, but other people need to get involved. But I have one question, more basic. Compared to other kind of science, what's special about DIY biology? Is it because of the application that's so widely affecting everybody, or is it because of the technology is getting easier to get the hands on that make it different from other kind of DIY, say physics or
right? So the question was, what makes DIY biology so particular, and why is DIY biology so why should they be paying attention to that in terms of other science? And I think the answer is that I don't think it is that important. I think if there are other sciences that you're interested in, there's no reason that you shouldn't engage with those things, But yeah, I guess we're just talking from our personal expertise of seeing, but I feel like if there are other sciences, if there's a science that you feel like you could integrate that science into your own life, and you could find different ways to do it, then there's no reason not to try. I think it's the same idea. What do you think, Mary?
Yeah, I think that curiosity in all sciences is good. But I guess what the documentary experience taught me in particular was that biotech is actually becoming extremely relevant in everyone's lives. And if you don't see it now, you're going to see it within the next year, because it's really, really advancing at this rate that is just ridiculous. And that's why I just think that people should have a basic literacy on biology in terms of the food that we eat and our health and our bodies. These are things that are extremely relevant in everyone's lives. And if DIY Bio is a way for you to engage with biology or a way for you to establish a relationship with biology, then I think that it can be useful in that aspect.
So one thing, Mary, that's very interesting is Nam was telling me that this group is actually planning GMO protests. Is that correct?
No.
Oh, it's not this. Oh, okay.
GMO discussion.
A discussion about GMOs. Okay, sorry, I got that wrong.
Don't make it big.
So I just am curious. What are you guys? What do you guys know about GMOs, and how do you guys feel about GMOs?
I think it's quite a new thing for us, especially from a government. So I just want to find out what it is, and I just take part in kind of workshop to make me more motivation to find out what it is, and maybe make me think more deeply about which is very good for our country or not.
Mm-hmm. So yeah, you're questioning whether it's going to be a good thing for your country or it's going to be a not a good thing. What about the rest of you guys? Any other thoughts or?
I think people trust the scientists so much because they even don't try to use their mind to analyze the idea. So I think this project will happen with some.
So he was saying that people have a lot of trust in scientists, you know, and they don't really ask these questions for themselves. Yeah, that's really a good point. It's very, very important thing to be aware of, you know.
Yeah, that's why he wants to be a scientist.
That's why you want to be a scientist.
He's a scientist, science.
Yeah, anybody else have any thoughts or any ideas or?
Well, for me, GMO is a kind of thing that you change the complete structure of the genome. You insert a completely new gene or something that differ greatly from the traditional methods like breeding. So I think GMO was based on an old sort of knowledge that genes exist as independent unit of life. But I think nowadays genes work in a interactive system. So for me, I personally don't believe that GMO will work independently. No.
You don't think they'll work independently?
Yes.
Do you mean within this country, or do you mean just in general?
No, I mean in the ecosystem. Not in the living bodies. So,
the GMO could affect our gene.
Your genes, yeah. Well, yeah. Go ahead. Sorry.
For example, when they make a tomato that can resist the cold temperature. Initially, they thought that by introducing a gene that encodes for proteins, which allows the tomato plant to resist the cold, they think that it would just modify a single gene and totally don't touch other genes. But my belief is that in the long run it would affect other genes, so other will work in a negative way. So I mean, I feel that there would be detrimental effects to the entire organism.
So, did you hear that, Mary?
I think there is maybe
No.
possibility that we can be X-Men.
You can say what? They can be what?
There can be a possibility that we can be X-Men.
Okay.
In a positive way.
So I guess he was saying that these technologies
it's unpredictable.
They're unpredictable, right? And that maybe by integrating certain genomes that we won't actually understand the effects that we're having on this tomato, on certain crops. Did you get that, Mary? Hello?
Yeah, I can hear. Yeah, go on.
So yeah, he was pointing out there's a gene in the tomato that they've been trying to. It's got a relationship to the temperature, right?
Yeah.
But he's saying that
Yeah, is it the flavor tomato?
The flavor tomato?
Yes.
Yes, it is. And he's just concerned that it would have more detrimental effects to the crop because I guess, and I think this is very true, we don't understand this technology as well as we think we do, right?
No, that's totally correct. And you should really look at the work of Adam Zareski because he talks a lot about this concept of not knowing the consequences of what we put into the environment. And especially a lot of these GMO products really, really harm the environment in terms of creating monocultures and polluting the area with pesticides. So yeah, we really don't know what kind of effects we're having on the environment and also to our bodies. I mean, of course, there's been kind of this lack of data on harmful effects of GMOs, but we only have 30 years of data. We don't know what kind of data we're going to get 50 years from now, 100 years from now. So we really don't know, basically. But lots of scientists will argue that in the kind of grand scheme of evolution, it's all random anyway. That's what they argue. It's like we're all just mixing DNA and seeing what comes out on the other end. So it's like, yeah, we're playing with life, but it's like nature plays with life already. So there's that kind of debate going on. So, I mean, you can be pro-GMO or anti-GMO, I don't care. I think as long as people initiate a discussion and talk about these issues, because, you know, people are voting on policies and all kinds of things. Like, major changes are happening, and the sooner you join the discussion, the better.
If you look at, and I think this is very important to consider, if you look at what happened in India with the GMO culture, it's really scary stuff, you know. Essentially, all these farmers have to keep buying seeds from Monsanto, and they get put into this cycle of debt, and there's just all these suicides happening because there's no way out of these awful debt systems, you know. So it's, you know, I think that your concerns about health are justified and worth considering, and there's also a lot of concerns in terms of the corporate and economic atmosphere that introducing GMOs are going to have.
Actually, I have known that if Vietnam try to use GMO product, it's from the example of the East Africa, the country, it seems that we have to maybe depend on the company that sells the seed with GMO.
Mm-hmm.
Right. And but I really like this kind of project because that try to show the freedom in the research, that try to bring those difficult things to the public.
Right.
Yeah,
that's true.
I really feel good because it's not in Vietnam.
Yeah, I mean, I think there's no reason not to start. You guys are clearly all super smart and have some understanding. Sounds like you said there are some people here that study biology, right?
It's very small number, and they are separately.
I mean, in this group here, there's people that study biology, correct or not? Am I going to correct? Yes.
I'm not sure.
There's people that study science, right? In general, yeah. So yeah, there's yes.
So I can see that Indonesia has accomplished something. So I think that Indonesia and Vietnam have some kind of similarities. So what do you think about the similarities that could make us and Indonesia could accomplish this project?
So the question was, Mary, what kind of similarities might exist in Vietnamese culture and in Indonesian culture?
She hasn't been in Vietnam.
But she's not been.
It's really hard to say because I've never been to Vietnam.
Right, but one thing I've noticed. Go ahead. Well, how about
I would assume that there's probably a lack of resources because when I was in Jakarta, there's definitely some instruments or devices that you could not get in that local area. So I think that is an advantage and a disadvantage. But I think the advantage there is that people really come up with innovative solutions to get the equipment that they need, which is the whole spirit of DIY. Basically, it's the whole spirit of hacking is just finding a solution to a problem.
So did you guys hear what she said? She just said that that there's opportunity here to find creative solutions to different problems. But one thing I've noticed personally, and I think Mary was telling me a little bit about this, is this kind of relationship with knowledge that you seem to have in Vietnam, right? It's just like learning and knowledge is very important to you guys, and just engaging with things in as many different ways as possible, through school and at home and whatever, through education and finding other ways to do it. So, yes.
I was curious about a slide which which talked about bioart and you're the artist. So could you please introduce?
Absolutely.
Explain more about
Mary.
it.
He has a lot more questions about bioart. So.
Oh, good.
Yes. So, do you have any specific questions, or you just want us to talk a little bit more about it?
I just want to know how these guys do with bioart. What they did.
What?
Amazing things they did.
Yeah, let's talk about some of our favorite projects. I'll let you start. Favorite bioart or bioartists.
There's a woman right now named Heather Dewey Hadford who is basically, she's looking for quote-unquote genetic samples, such as fingernails, saliva, chewing gum, cigarette butts, and she's extracting that DNA and constructing DNA portraits, 3D portraits out of those DNA samples, which is, so the project is really talking about this idea of genetic privacy, and it's kind of also speculating on a possible future where your genetic samples could be used for, I don't know, surveilling you, or for surveillance, or for this sort of kind of negative reasons. So I think it's a really good project on a speculative and conceptual side, and also it's really, really good technically.
So one of my favorites is the guy in the middle, who I didn't really talk about in too much specifically. His name is Adam Zaretsky, and he's like a performance artist. So he is actually very interested in the same questions that you were asking, in terms of, well, we don't really understand this technology. We don't actually know what we're doing to our environment. We claim that we do, but we don't, right? So what he kind of does is he does that, but he does it to the absolute extreme. So he just goes, I'm just going to take this gene, and I'm going to stick it into this, and I'm going to take this, and I'm just going to stick it, and I'm just going to see what happens, you know? And it's all this kind of like performance about, you know, what it means to just put, you know, things and different things, just to freak people out and just ask questions. And
I'm mixing drink.
Mixing drinks, exactly. That's one way of thinking about it. But we're mixing living things. So you know, as you can see, there's a lot of people asking more of these critical questions, you know, and also in the documentary, you saw the last part where the bioartists and their kind of interest is to take these questions, right? These questions that are happening in laboratories, maybe not as much as they should be, and bringing these questions to a larger audience, bringing them to exhibitions, bringing them to museums, you know, bringing them to everyday people, and having these kind of atmospheres where everybody else can start having discussions about what's happening here. And so we think that's really important, you know, is to, you know, be very excited about these technologies, but also be asking these critical questions about what it means for these technologies to be integrated in our lives.
Okay, it's getting late, so just one last question. Okay.
I'm curious about the future fields of synthetic biology. Like I saw in
synthetic fuel.
Future fields for synthetic biology. Like I saw a Kickstarter or a project on Kickstarter. Like they are making glowing plants. Yeah.
Oh.
So what are the future fields for synthetic?
So guess what? That somebody here. That's funny. Our next episode, we actually interviewed those guys, and our next episode, we are going to be talking about the Glowing Plant Project. So he was asking us about the Glowing Plant Project, but more specifically, he was asking us what future fields in synthetic biology are going to look like.
It's unprintable.
Mary?
Sorry, what was the question?
He was asking what we think future fields in synthetic biology are going to look like.
Fields, well.
Like, how about future uses?
There's a lot of uses. There's a lot already. Let's see. Here's one thing. I think a lot of applications now are at the industrial scale. they're at the really high, like, corporate level. And what we've yet to see really are just consumer end products in synthetic biology. And we'll probably see more of that in the future. As like, you know, DIY Bio has more of an influence and this whole maker culture and these fab labs and tech shops and how these things become more popular, then I think we'll see more consumer end products coming from synthetic biology. Of course, growing plants is one of the first projects, I think, to really reach like the everyday consumer, because it's just this really like simple, pitchy idea that people really just find inspiration in. So I think you'll see like more little devices or even people are talking about apps. Like people are talking about these downloadable apps to kind of do your own synthetic biology, to create your own organisms, basically. So I don't know. It's all very transhumanist, but I think we might expect stuff like that in the future.
So I think what she was talking about is taking this thing that used to be an industrial science, right, where it's like only industries will use it, and you know, using it for manufacturing it and personalizing it, you know, so that it becomes something that's accessible to everybody, and it starts being used for things that, you know, directly to that a consumer is interacting with. You know, for instance, like you were saying, the glowing plant project, right? This is not something that's being sold to a pharmaceutical company. This is something that's being sold directly to the consumer, right? So this is probably going to start happening. And she was mentioning maybe an app that you can download and start doing DIY Bio by yourself at home, you know. So, cool.
Okay, thank you everyone.
Thank you guys. All right, Mary. You can go back to sleep. Thank you so much.
Good night.